Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0118 indicates a high voltage condition in the engine coolant temperature ECT sensor 1 circuit. This sensor is crucial for monitoring the coolant temperature flowing through the engine and provides critical information to the engine control module ECM or powertrain control module PCM. Located typically near the thermostat housing, the ECT sensor helps ensure optimal engine performance, fuel efficiency, and emission control. A fault in this circuit can lead to poor engine operation, increased emissions, and even engine overheating. Before proceeding with troubleshooting, it is essential to record all freeze frame data and conduct an onboard snapshot to understand the conditions under which the trouble code was triggered. Understanding the operation of the ECT sensor is vital since it directly affects the vehicle's performance and correctness of its system operations. The Engine Coolant Temperature Sensor, ECT, is a pivotal component that measures the temperature of the engine coolant circulating within the cooling system. This sensor plays a critical role in regulating engine performance and efficiency by communicating temperature data to the engine control module, ECM, or powertrain control module, PCM. Typically positioned near the engine's thermostat housing, the ECT sensor ensures that the vehicle runs smoothly by allowing the PCM to adjust fuel injection and ignition timing based on coolant temperature readings. If the ECT sensor detects temperatures indicating near freezing conditions or excessively high voltage, it will signal the PCM, which would prompt the activation of a fault code, such as P0118. Identifying the exact location and function of this sensor is crucial for troubleshooting, as any issues in its circuit can lead to significant engine operational problems. The high voltage reading indicated by DTC P0118 can stem from several potential issues. Firstly, the ECT sensor itself may be faulty, leading to inaccurate readings sent to the PCM. This can occur due to sensor wear, damage, or internal electrical failures. Secondly, wiring issues, such as frayed or damaged wires in the ECT sensor circuit, could cause a disruption in data transmission or false readings. Thirdly, poor electrical connections, particularly at the sensor or PCM connector terminals, may result in intermittent failures. It is crucial to inspect these connections closely, as loose or corroded terminals can lead to intermittent operation of the sensor, producing unreliable data. Each of these causes can lead directly to triggering the P0118 error code, emphasizing the need for thorough checks during the diagnostic process. Symptoms related to the P0118 code can range from subtle to severe. Drivers may notice engine performance issues, such as rough idling, stalling, or poor acceleration, all of which can result from incorrect temperature readings affecting fuel and ignition timing. Moreover, increased emissions may occur due to improper fuel-air mixture adjustments made by the PCM, which can lead to compliance issues with environmental regulations. Additionally, a persistent check engine light will illuminate on the dashboard, prompting the driver to address the underlying issue. Ignoring these symptoms can lead to further complications, such as engine overheating or damage over time, making prompt diagnosis and repair essential to vehicle longevity. In summary, the consequences of this fault code can significantly impact overall driving experience and vehicle upkeep. The first step in troubleshooting DTC P0118 is to turn the ignition switch to the on position, also known as II. Once the vehicle is in this state, the technician should access the vehicle's data list using the Honda Diagnostics System HDS tool. A crucial measurement to check is the reading from the ECT sensor, which should register a temperature around -40 degrees Fahrenheit, -40 degrees Celsius, or a voltage reading of 4.92 volts or more. If the reading indicates these extreme values, it suggests that there is a problem in the sensor circuit requiring further investigation. If the sensor reads normal values, it might indicate an intermittent failure in the system, warranting checks for loose connections or terminal integrity at both the ECT sensor and the PCM. This initial assessment is fundamental for directing subsequent troubleshooting efforts effectively. In the second step, the technician should turn the ignition switch to the lock position, denoted as 0. Following this, the ECT sensor 1 needs to be disconnected, specifically removing the 2-pin 2P connector. A practical diagnostic technique is to use a jumper wire to connect the terminals number 1 and number 2 of the ECT sensor 1 connector. The wire should be placed carefully to ensure it makes good contact without shorting any other terminals. This method essentially creates a bypass around the sensor temporarily, allowing technicians to measure the circuit condition more effectively. Once the jumper wire is securely in place, the next step involves turning the ignition switch back to on to observe the new readings from the ECT sensor data list. This helps identify if the issue lies within the sensor or the wiring leading to the PCM. Once the jumper wire is connected, the technician will again turn the ignition switch to the on position, allowing the system to power up. It is essential to again check the ECT sensor 1 data in the HDS to determine the temperature or voltage readout. The focus remains on whether the reading shows approximately -40 degrees Fahrenheit or -40 degrees Celsius or less, or displays 4.92 volts or more. If this condition holds true, it further indicates circuity issues and suggests that the wiring or connector terminals may need examination. If the measurement deviates from this pattern, technicians should proceed directly to the further troubleshooting steps, while ruling out any significant direct failures in the ECT sensor itself. This process systematically narrows down the fault through logical checks and measurements. The fourth step in addressing DTC P0118 involves first removing the previously connected jumper wire from the ECT sensor 1-2P connector. Once the jumper is disconnected, the ignition switch should again be turned to the on position to ensure the system is active and can provide readings. The next action requires measuring the voltage between terminal number 2 of the ECT sensor 1-2P connector and the vehicle's body ground. This measurement is significant as it will help determine whether the circuit is functioning properly or if there is an electrical issue present. A healthy voltage reading would typically indicate the circuit to be intact and functioning well, while an abnormal voltage could further suggest wiring defects or failures within the ECT sensor itself. This careful measurement provides insightful data towards diagnosing the root cause of the high voltage problem indicated by the P0118 code. After completing all necessary repair actions associated with the P0118 code, it is essential to ensure a proper final verification process. This involves retesting the ECT sensor and its circuit, confirming that all parameters now align within manufacturer specifications. Following this, the DTC should be cleared from the vehicle's onboard diagnostic system to reset the check engine light. Conducting a test drive afterward will allow the technician to observe any possible reoccurrence of symptoms related to the ECT sensor circuit issue. This ensures that the repairs made were effective and that the vehicle is functioning correctly under real driving conditions. Additionally, reviewing freeze data post-repair helps affirm that previous erroneous conditions have been resolved, thus confirming a successful repair. To prevent future occurrences of DTC P0118, implementing a routine preventive maintenance schedule is crucial. Regular inspections of the ECT sensor connections and wiring can help catch any developing issues before they escalate. Checking for corrosion, loose terminals, or physical damage can serve to uphold the integrity of the electrical connections involved in the coolant temperature sensing circuit. Additionally, evaluating the functionality of the ECT sensor at regular service intervals can preemptively address aging effects or failures occurring due to wear and tear. If the sensor is found to be misreading frequently or showing signs of fault, prompt replacement can help limit repair costs and ensure vehicle reliability. Keeping these aspects in check can significantly enhance the overall durability and efficiency of the vehicle's cooling system. In conclusion, addressing DTC P0118 involves a comprehensive understanding of the engine coolant temperature sensor and its critical role within the vehicle's operation. The outlined systematic troubleshooting steps provide a clear pathway to diagnose and rectify any faults associated with this DTC effectively. Key factors include understanding the sensor's wiring integrity, voltage readings, and possible component failures that could lead to erroneous readings. Additionally, preventive measures such as regular inspections and timely replacements of sensors can help enhance vehicle performance and minimize further complications. Ultimately, accurately diagnosing this trouble code ensures the smooth functioning of the engine and contributes to the overall safety and efficiency of the Honda Odyssey. Please like and subscribe to the channel. See you next time!